This is the Lone Crater YouTube. We hope this video helps.
You start by verifying hardware and drivers. This prevents later surprises. Once you confirm GPU model and VRAM, install the vendor driver and the matching CUDA or ROCm stack. Make sure the framework build matches the runtime, install TensorFlow or PyTorch GPU wheels, or compile with CUDA support. Also set up environment variables now so paths and CUDA home point correctly. Running a quick NVIDIA SMI or RCMinfo verifies visibility. If that completes, you're ready to move to configuring code and runtimes. You now modify runtime and application settings to actually use the GPU. First, set the device explicitly in your code and move tensors or models to that device. That tells the framework where to allocate compute. Next, optimize data pipelines to feed the GPU consistently. Use prefetching, pinned memory, and parallel loaders. Then tune batch size and enable mixed precision or AMP to increase throughput while managing VRAM. Finally, enable memory growth or limit GPU memory fraction so the process coexists with other apps. You finish by validating and monitoring. Run a focused benchmark or a short training step to confirm GPU utilization. While it runs, watch NVIDIA SMI or NVTOP and framework logs to ensure high compute and low CPU bound stalls. If the GPU isn't used, check common problems: mismatched CUDA/driver versions, forgetting to move model or data to the GPU, or hitting memory limits. If needed, reinstall matching runtimes or enable verbose device allocation logs. That single troubleshooting step often reveals the root cause.
Thanks for watching. Consider subscribing if we helped you.